And welcome. Today we're doing a question from LeetCode called minimum window substring. It's a hard, we're going to jump right into it. Given two strings s and t of lengths m and n respectively, return the minimum window substring of s, such that every character in t, including duplicates, is included in the window. If there is no such substring, return the empty string. The test cases will be generated such that the answer is unique. Example 1, we have the following input string s, and we want to find all the letters in t in s. So the smallest substring to do so, the minimum window substring, will be B, A, and C, and it has all the letters in T. Example 2, we have A and A, so of course our output is all of S, which is just A. And example 3, we have A, and T, and just A in S. So we're not actually able to find every single letter in T in S. We need two A's, but we only have one, so we return the empty string. And we have some constraints over here. S and T consist of uppercase and lowercase English letters. Follow-up, could you find an algorithm that runs in O of m plus n time? What do we want to do? We want to find T within our string S and return the smallest substring to do so. If we can't find it, we return the empty string. So like always, we're going to start off with an example. So I have example 1 over here, and I'm going to go ahead and modify this just a little bit. So I'm going to add another A in T and a few more in S. So this is our input S, and this is our input T. Now, what do we want to look for in S? Well, let's go through all the letters in T and check exactly what we want to look for. We have one A in T, so we need at least one A in S. Then our next character is another A, so we need two A's in S. Now we get one B, and finally one C. Now these are the character counts and characters that I want to see in S. I want a substring with all of these in there. So let's just start off in the beginning. I'm going to say my substring is going to start over here. The first thing I'm looking at is this first index. So my substring right now, the leftmost point is at 0, and I'm going to say my rightmost point is also here. We're going to say both are inclusive. So what character is at index 0? That's an A. And A is something that we need. So we're going to go ahead and take it, right? We need an A to make T, and we need two of them specifically. But now that I've seen this A, I'm going to decrease how many I need. I no longer need two, I just need one. So now that I have one A, I still need another A, another B, and another C. So let's expand this substring to look for the other characters. Moving right down, I come across a D. I don't really care about a D, it's not a character that I'm looking for, so we're gonna ignore it and keep expanding our substring. The next one is O, same thing, we don't really need that. Move on to the next one. Right now my substring is ranging from A to B, so it's going from A, D, O to B. Now at B, we see that it is a character that we need, so we're gonna go ahead and update our counts. We no longer need one B, but now we need 0 Bs. And now that we need 0 Bs, we have one character fully formed. So I'm also gonna keep track of all the letters that we've fully formed. Right now we formed one, and we are looking for 3 in total. So in total, we need 3, and so far we formed only 1. Now, why are we keeping track of this as well as this? This represents how many counts of each character I need, and this is going to represent how many characters I've found. Once I've found all the characters that I need, that means an entire character has been found, and we're going to increase this formed count. Once this reaches a total, we found all the letters we need of all the counts we need them, and we know we have a valid substring that encompasses all the letters in T. So right now we have one letter down, we still have 2 more letters remaining, which means we just need to continue expanding. We're going to move R down again. So now we're at E. It's not something we're keeping track of, so we don't really care. We move down. Now we come across an A, and it is something we need, so we're going to decrease this count to 0. Now that we've hit 0, we've finished an entire character. We no longer need any more A's, so our formed is now going to be bumped up to 2. We have 2 characters fully done, all the counts that are required for them. We're still not at total, so we keep expanding. Now I go over here, and I'm at C now, which is something I need. It is a letter that we're keeping track of. So I'm going to decrease this count by 1. And now that I'm at 0, I increase formed to be 3. And we've formed all the characters and corresponding counts that we need. So this right here is a valid substring. And right now, I didn't really have a valid substring, so I'm going to say the length of my answer is going to be the size of this substring. So it's going to be 1, 2, 3, 4, 5, 6, 7. And I'm also going to keep track of the left and rightmost points of my substring. So substring left and substring right are going to be 0 and 6 respectively. And right now I'm going to say that this is inclusive. So from 0 to 6 is a substring that encompasses all the letters in T. Now that we were able to form everything we need, we want to see if we're able to sort of shorten our substring. Can we get smaller and still be valid? So in order to decrease the number of letters in our substring, we're going to move left down. And I'm going to write this below just so it's clearer. Now, this is a character we need. So once we move this down, we'll need another A. So we're going to increase this count. And now that this count is no longer 0, we haven't been able to form all the characters. We've only formed 2 within the substring. So we need to expand again. And we're going to move right down here now because we've already covered everything to the left of us. So moving right down, we come across an O. We don't care about that. We're looking for an A. Moving this down again, we're at D, don't care. A, this is something we need. So we're decreasing the count to 0. And now we formed everything again. So this goes back to 3. This is another valid substring. Now, what is the length of this substring? This is 9. It's greater than the one we've been keeping track of, which was the length of 7. So really, we don't need to make any updates here. We want to see now if we can go smaller. So we're going to bring left in. We're at D right now. It's not in here, so we don't care. We can just move it in. We're at O. And now what is the length of this substring? It's 8. It's still not smaller than the one we have, so we keep moving it in. Now we get rid of the O, and we're still valid. So what is the length of this new substring? This is 7. It's not better than the one we have, so there's really no need to update. We move this down again, but this character that we're getting rid of was something we're keeping track of, so we're going to increase this count, no longer 0, which means we haven't been able to form all of our letters, and we now need to expand. So moving down, we're at E, we don't care, and now we're at A, which means we're going to decrease this count by 1. So now A is at -1. We have an extra A. And we don't really change formed over here because we didn't go to 0. We're just going below 0. We have extra A's, but we're still looking for a B, which we haven't formed. We've already formed our A and C, but the letter we're missing is B. So we still need to keep expanding. Moving this down over here, we finally get to B, which means we decrease this count. It goes to 0. And now we've been able to form all of our characters and all the character counts. So what is the length of this substring? This is 9. Greater than the one we have, so no updates needed here. And now we want to decrease it because we're able to form everything we need. So moving left down, we're getting rid of an E, which we didn't really care about. Now we're at A. What's the length of the substring? This is a length of 8. Still no updates needed. We move this down. We got rid of an A, which we had an extra of, so now this is going to go to 0. We're still good. We have all the characters we need. So now we're going to check this substring. This is a length of 7, which means no updates are required. Our substring still encompasses all the letters needed in T, so we can see if we can still bring this smaller. So we're bringing left in again, which means we got rid of C. We need another C. We no longer have all the characters we need, so we're bringing form down. And now we need to keep pushing out. So we go to A, this becomes -1. We continue pushing out, we now get N, we don't care about that. Push out again, we're at C. So now this is 0, and we formed all the letters we need. We check the substring against what we have right now. The size is 9, no updates are needed. Now we just shorten our substring. So bringing left in, we got rid of an O, not something we cared about. Get rid of a D, again, not something we cared about. What is the length of the substring? The length of the substring is still 7. It's not less than what we have, so no updates are needed. We push left in again. We just got rid of an A, so this is going to increment a count by 1, but we still don't need any additional characters, so we're still good to go with our substring. So checking this, we have a length of 6. This is smaller than one we had, so we're going to go ahead and update this. And what are our new substring indices? That's going to be 10 and 15. These are inclusive, but this substring going from E, A, B, A, N, C includes all the letters we need from T. And since we're good to go, we have all the letters we formed, we want to see if we can even get smaller right now. So moving this in over here, we got rid of an E, not something we're keeping track of. We don't really care about it. We're checking this size now. We have 1, 2, 3, 4, 5. It's smaller than the one we have, so we go ahead and update this again. And our new left and right endpoints are going to be 11 and 15. Now we bring this in once more. We got rid of an A, so now A is 1, which means we haven't been able to form all the characters we need. It means we need to keep pushing out. But there are no more letters to continue going out to. We can't continue pushing back. Right is already at the last character, which means we just checked everything we could check. Which means the smallest substring to include all the letters in T was 11 to 15 inclusive. And this is how we're going to solve this problem, right? We just need to keep track of all the characters we need, keep counts of how many are remaining, if we've been able to form all of them. And if we have, we're going to see if we can update the current substring that we have. If so, we just update our left and right points for a substring and return that substring in the end. So let's go ahead and code this up and then run through an example. Right, to code this up, the first thing I want to do is define a dictionary that's going to keep track of all the letters and the corresponding counts that I need to find in S. So I'm going to define this dictionary over here to be a default dictionary of integers. And I'm going to import this from collections. So from collections, import default distinct. And this makes it so that we don't have to explicitly define every single character in D and then increase that count. This just condenses the code a little bit. So now that we have our default dictionary, we want to go through every single character in T and add it to D. So for character in T, D of that character plus equals 1. That's how many counts of every single character that we want in a substring of S. So now that we have that defined, we need to initialize all of our variables. So formed is going to begin with 0. And what are the total characters that we need? That's going to be the length of D. How many characters do we need in total? So total is going to equal length of D. Now we want to initialize our left and right pointer. So L is going to equal R, which is going to equal 0. They're going to both start at index 0 over here. And we want to initialize these variables over here. So the length of our answer, we're going to say it's going to start off at float infinity. And this is because once we come across a substring of a length smaller than our answer, we can go ahead and update length of answer as well as the left and right endpoint. So we want to start this as high as possible. So it's at infinity, and substring of L of R are both going to be 0 and 0. Now we want to loop through all the characters in S, and we do that up until we can still keep expanding on the right. So while R is less than the length of S, we can keep checking all the substrings. Now, what do we want to do? We want to check the letter that we are on, the character we're on with our right pointer. So character is going to equal S of R. And we want to check if it's in the dictionary. If it's not a character we care about, we're just going to keep moving right down. So in the end, we're going to do R plus equals 1. But if this character is in D, so if character in D, what do we want to do? We want to decrease that count because we'll need one less of that character. So D of character minus equals 1. And if that count goes to 0, we've been fully able to form one of the letters that we need. So if D of character equals 0, we're going to increase formed by 1. So formed plus equals 1 because now we formed one of the letters we need completely. We've hit 0. So what happens once total equals formed? If that is true, we want to keep pushing left in, and we want to keep doing that while we can still push left in. So while left is less than right, and formed equals the total number of characters that we need, we know we have a valid substring that encompasses all the characters in T. So we want to check if the substring we're on has less characters than the one we're keeping track of so far. So what is the length of this substring? So that's going to be right minus left plus 1. So current length is going to be R minus L plus 1. And why do we do plus 1, right? Say our left pointer is at A and our right is at D, so we want to look at AD. If we do 1 minus 0, we'll get 1. But our actual length is 2, right? To make it inclusive, we're going to add this plus 1 over here. And now we want to check if current length is less than the length we're keeping track of. So if current length is less than the length of answer, we're going to update our left and right substring endpoints as well as the length. So length of answer is now going to equal current length, and substring of left and substring of right are going to equal left and right respectively. And I'm going to add a plus 1 to right as well. And why are we doing plus 1? Because if we were to take a substring of, say, S 0 to 2, it would be up to but not including 2. It's not inclusive, right? So we'd go from A to D, but we wouldn't include the character at the second index. So we're doing plus 1 here to be able to include that. So now that we've made all of our updates, we want to see what character we're actually getting rid of, right? So the character at S of L, this left pointer that we're going to get rid of, we want to check if it's in the dictionary. If character in D, so if that character count was at 0, that means we're no longer able to form that entire letter. So if D of character equals 0, that means formed minus equals 1. We still need another letter to make. And either way, we're going to increment that count by 1. So D of character plus equals 1. We'll need another one now. We no longer have as many counts of that character as we did. And once all this is done, we move left up by 1. And once we finally break out of this while loop, we want to return the empty string if our answer still equals float infinity. So return the empty string if length of answer equals float infinity. Else we return the substring. Else we return substring of sub L to sub R. So let's go ahead and submit this. Okay, import error. Default. This should be spelled default like so. Go ahead and submit this again. Wrong answer. We have A and A. Let's just go through this really quickly. Oh, this should be less than equal to, because if it's a size of 1, if left and right are at the same thing, we can still process this. So let's go ahead and submit this now. And it is accepted. So talking about space and time complexity. For space, We'll only ever have a dictionary as big as the number of letters in our alphabet, both lowercase and uppercase. So this is actually going to be constant O of 1. It doesn't matter how big S or T get. The size of our dictionary is going to be capped. So that's going to be constant in space. As for time, this is going to be an O of N plus M solution, what we were requiring over here, because we're going through T1s just to keep counts of all of our characters and counts, and then as we go through with 2 pointers, so this is also an O of N if N characters are in S, plus M if there are M characters in T. Now before leaving, let's just run through a super quick example just to go line by line through our code to make sure we fully understand what is happening. Okay, say our input S is YYY and our T is EYE. We want to look for EYE within a substring of S, and we return the empty substring if we can't find anything. So just going through this super quickly line by line, the first thing we do is initialize our default dictionary. So that's going to be over here. And now we go through every single character in T and add 1 to all the keys and character counts in D. So looping through, we go through this first character, which is E, and this has a character count of 1. Then we come across a Y. This has a character count of 1. And finally, we see E again. We increment that character count by 1. So now we have 2 E's. So this is our dictionary. Now we do all of our initialization. So formed is equaling 0. Total equals the length of our dictionary, which is 2. Left equals 0. Right equals 0. The length of our answer equals float infinity. And substring of left equals 0. Substring of right also equals 0. So now we want to loop through while right is less than the length of S. So that is true. Right is less than the length of S. Right is 0. We're setting our character to be S of R. So that means R is over here and our character is Y. We want to make a check. If character in D, that is true, it is in D, we're decreasing that character count by 1. So now this is 0. And if that character count is 0, which is true, D of character is now 0, we're going to increase formed by 1. We've been able to fully form all the character counts we need for one character. Now we go into this while loop over here, while left is less than equal to right, which is true, and formed equals total. That's not true. We haven't been able to form all of our characters. This is 1, this is 2. So we skip out of this while loop and increase R by 1. We want to expand our substring looking for the remaining characters. So now R is 1. So now we are at this Y. And actually, this string should have had an extra E on this end over here. Okay, so back in this while loop, this character is now Y. We want to make a check. If character in D, it is in D, so we're going to decrease this count by 1. So now it's at -1. But this character count isn't 0, so we can't increase formed by 1. We didn't completely make a new character, right? We just have extras of Y, so we can't actually form another character completely, which means we don't increment this by 1. Now we go in this while loop, while left is less than equal to right. That's true. And formed equals total. It's still not true, so we can go in here. We increment right by 1 again, so now we're at 2. So now R is in 2. This character is in our dictionary. We decrease this count by 1. We don't go into this if statement, and we still don't go into this while condition. Formed doesn't equal total. So we increment R again. And now our character is E. It is in our dictionary, so we decrease that count by 1. Now this doesn't equal 0, so we weren't fully able to form this character, which means we're in this condition now. And formed doesn't equal total, so we can't go in this while loop. We increase R again. R is now at 4. We repeat the same thing, right? Decrease this count by 1. We can't form anything. We just bump R up. Another Y, so we're back in this for loop. Decrease count again. We still can't increase form because we can't increase the number of characters we've been able to form. So we still can't go into this while loop, which means we still continue expanding out. R is now at 6. We go back in the while loop. Our character E is in our dictionary, so we decrease that count by 1. It's now at 0. And we increase formed by 1. We were fully able to form another character, which means this is 2. And since we needed a total of 2 characters fully formed with all their character counts, and we were able to do that, and left is less than equal to right, we finally go into this while condition. Now, what is the current length of our substring? L was over here, right? We didn't actually end up moving L, so L is still at 0, and R is over here at 6. So the length of our substring is 6 minus 0 plus 1, which is a total length of 7. This is less than the length we're storing, which is infinity, so we're going to go ahead and update this. So our new length is 7, and our left and right endpoints are updated to be left and right plus 1, which is 7. Now we try to shorten our substring. The character at left is going to be S of L, so that's going to be Y. And we see that it is in the dictionary, but it's not 0, so we don't need to unform this character. We're just going to add 1 to this. So it goes from -4 to -3, and we increase L by 1. So we go back in this while loop. Both of these conditions are still true. We check the current length. It's smaller than the one we had, so we make all our updates. And our new left endpoint is 1. We check the character we're on. It is in our dictionary, and it wasn't 0, so we don't need to unform anything. We just increase this count to be -2. And we push left in. So left is now 2, and this moves down here. We do the same thing again. This again is a smaller substring, so we update this again. This is 5, this is 2, and we increase this count by 1. And we move left in. So left is now at 3. Back in this while loop, form the equals total. Left is less than equal to right. What is the current length over here? Well, that's going to be 4, so we go ahead and update that. And now our left endpoint is at 3. Right is unchanged. And we see if the character we're on, E, is in the dictionary. It is, and it was 0. So now we have 1 less E because we're moving this left down. So we decrease this count by 1, and we increase that character count by 1 because we are now in need of another E. And we push left in. So now left is at 4. We go back in this while loop. Formed no longer equals total. So we break out of here and increase R by 1. So now R is 7. We go back in this while loop, and it's no longer less than the length of S. So we exit. There's no other letters to process. So we return over here. The length of our answer doesn't equal infinity, so we don't return the empty string. Instead, we return the substring of S going from 3 to 7. Which means this is the substring over here. EY by E is a minimum window substring that has all the letters from T. So we just went ahead and solved a minimum window substring from LeetCode. If you have any questions whatsoever, of course, let me know down below. I will answer all of them. If this video was helpful, like, comment, and subscribe. It really supports the channel. And as always, I will see you in the next one.